Okay. After that example, and the first example, and this question, we've pretty much talked about everything, but just to make sure you know 100%, we'll do one more example. This example is going to be a combination of both of the last ones, because here's one where we're multiplying f and we're adding something. So we're going to do a scale factor and we're going to do a vertical shift together. So I'm going to make a random equation, and what I want to do is I'm going to have a scale factor of 1/5, then shift down. Whatever you get after you do that scale factor, I want you to shift down by 6. And let's see how that would work. If we're going to do a scale factors mean we're going to multiply. Let's do this first with a table. X, f of x, and then j of x. Let's just pick some easy numbers. 0, 1, 2. F of x is going to do, it's just going to take those numbers. It's going to do 2 times 0 plus 4. That gets 4. 2 times 1 plus 4 is 6. And then this one's going to be 8. J of x is equal to 1/5 of f of x. Then we're going to subtract 6 off of that. So to get a number here, we're going to do 1/5 times 4, because that was the answer, that was the output for f, and then we're just going to subtract 6. Again, we're going to do 1/5 times 6 minus 6, 1/5 times 8 minus 6. So what do we get here? We get 4/5 minus 6, 6/5 minus 6, 8/5 minus 6. What do we see that is in common? Well, they all have a minus 6 at the end, and that's because a vertical shift always happens after you do any multiplication steps. The vertical shifts always happen last whenever you're applying a transformation. So you'll say that scale factors take priority over vertical shifts. In transformations. Scale factors take priority over vertical shifts and transformations. Now let's get the actual answer. 4/5 minus 6 is going to be a -5 and a fifth. 6/5 minus 6 is going to be a -4 and 4/5. In this last one, 8/5 minus 6 is going to be a -4 and 2/5. How I got those quickly is I actually just did the -6 and then I added that other number to that negative number. Let's get a graph and see how this looks. And the y's I need are 4, 6, 8. Okay, so let me extend this a little higher. Let's count by 2s. 2, 4, 6, 8. And I also need some negative numbers, down to -6, -2, -4, -6, and now let's put some dots. I use orange for f 0, 4, 1, 6, 2, 8. This was our original line. Then I'll do, okay, since the whole graph is red, I'll use blue for j of x. We have 0 with negative 5 and 1/5, like around there. 1 with negative 4 and 4/5. And 2 with negative 4 and 2/5. There we go. Now it's going through all 3 dots. Okay, now let's look at these lines and say what's different about them. We're in slope-intercept form. What's different? Do they look like they have the same slope? Well, if they have the same slope, they would be parallel. Are these 2 lines parallel? They're not. So the m changed. How did it change, though? Is the blue line more steep or less steep? Would you say that the blue line has a higher vertical rise? If you were climbing up a hill, would this blue line be easier to climb up or harder than this orange one? If you're a little person walking up a hill, would the orange one be more steep or would the blue one be more steep? The blue one is less steep. It's easier to walk up. So the m changed by that scale factor of 1/5. And now let's see how much the other thing changed. The vertical shift, we started at 4 for the y-intercept, and then we went down, not by 6, but we actually went down by like negative 11. So the entire vertical shift was more than just 6. Let's see what actually happened here. And to see what actually happened, we need to write the 2 equations. So m equals, oh, well, we already know the original y. We already know the original function was f of x equals 2x plus 4. And then j of x was 1/5 of f of x minus 6. So let's just do some substitution. We're going to take that and put it all right there. And I'll use a different color for it. So 1/5 times, we're going to take that 2x plus 4 and just put it in for f of x. 2x plus 4 is going to go right where f of x was. Then we're going to put the minus 6. I'm running out of space to the right, so I'm going to go down now. So we're going to distribute this 1/5. That's going to make 2/5 of x. And then 1/5 times 4 is going to make 4/5. And it's going to be positive. And then we're just going to copy that minus 6. Okay, so there's only one thing with x. 2/5 of x is the only x. And then we need to combine the 6 and that 4/5. And that looks pretty familiar to me, so let's just see what we got for that. The 6 and the 4/5 makes negative 5 and 1/5. That's why you gotta write your work down, so that way you can remember, I've seen that number before, and I know that answer already. J of x is equal to 2/5 of x minus 5 and 1/5, which would be 5.2. Let's compare these now. Let me write it one last time right here. 2/5 x minus 5 and 1/5. That's j of x. And yeah, we can see that m became lower between this slope and this slope. J of x is a lower slope, and the y-intercept is about 9.2 lower. So m changed by 1/5, and b decreased by 9.2 units. Alright, so that's actually a lot more complicated. You won't have to go that deep. All they're going to want you to do is, like I showed you at the very start, know what it means when you multiply by something, know what it means to use a scale factor, and to be able to use a vertical shift after you do that scale factor. Let's see how you do on some problems today.